Hi again, and welcome to Artificial Intelligence and Machine Learning Foundations course. When working with your machine learning projects, you will be dealing with large amount of data. And because machine learning is a field that is mathematical in nature, you would need a good working knowledge in data structures to help you solve real-world mathematical problems. In this lesson, we'll discuss the built-in data structures in Python that you can use right away. These include list, tuple, dictionary, and set. These built-in data structures allow you to organize, store, and manage your data. These allow you to perform operations on your data accordingly and help you accomplish your programming task a lot easier. First is list. List is a basic sequence used to store data of different types in a sequential manner. For example, to create a list, you use the square brackets and add elements into it accordingly. List 1 consists of 4 elements, and all items are of type string. List 2 also consists of 4 elements, but each item in the list is of different type. If you do not pass any elements inside the square brackets, you'll get an empty list. List items are indexed. The first item has index 0. The second item has index 1. The third item has index 2, and so on and so forth. This is called positive indexing. In Python, there is also a negative indexing. This enables you to access elements from last to first, which starts from index -1. So if I print the list 1 at index -1, it will display Levet. Then the item at index -2 is Jewel, and the item at index -3 is Sam. List items are ordered, changeable, and allow duplicate values. Ordered means that the items in the list hold a relative position and have a defined order. Changeable means that list is mutable. For example, you can add elements to a list by using any of the following methods: append, extend, and insert. The append method adds a single element to the end of the list. The extend method adds multiple elements to the list one by one. In effect, it increases the length of the list by the number of elements that are provided to the method. Now, you must know that when you use the append method to add multiple elements in a list, it will be added as a single element only. The insert method adds an element to the list by passing the index value as the position of the new item to be inserted, thereby shifting all the elements in the list, increasing the list size by 1. You can also delete elements from a Python list in several ways. You can use the del keyword or the methods remove, pop, and clear. You use the del keyword to delete specific item in a list using the specified index number. For example, this code removes the item at index 2 from the list, which is Liana. To remove an element using its value, you use the remove method. This removes the first occurrence of the specified value from the list. Note that if the value supplied does not exist, it will throw an error message or an exception. So in Python, you can handle a simple exception and do something like this. Or you can apply a more straightforward approach like using if-else statement. However, if you want to delete an item from the list, but you want that the deleted item's value to be returned after it has been deleted, then use the pop method. In here, I deleted the element at index 6, which is shine, and the returned value is stored in the variable deleted. And you can see that the element shine has been removed. You can access elements in the list the same way you would access elements in a string. For example, you can use a for loop to access individual elements in the list and print each item one by one. Or, I can access the list value at index 6 and assign a new value to it. In Python, list slicing is a common practice and most used technique by programmers to solve problems efficiently. One way to do this is to use the slicing operator colon. For example, to access elements from index 0 up to index 2, you would write 0, 3. This excludes the ending value at index 3. You can also omit the starting index, and this implies that the beginning index is at index 0. You can omit the ending index, and the slice will include everything from the starting index up to the last. So aside from the starting and ending index, you can also specify the steps. You can also use negative indexing to slice the list. In this example, we start from index -4 up to index -2, excluding index -1. You can also use slices to reassign a subset of items on the specified range. Or specify the slice to be deleted. There are also other useful functions and methods that you can benefit from when working with lists. For example, you can use the built-in len function to get the length of the list, string, or other data structures. The index method finds the index value of the item being passed where it has been encountered the first time. Say, if I have a list of numbers 5, 14, 10, 4, and 10, and if I want to know the index of the item with a value of 10, I can do this. The count method counts how many times the value exists in the list. In this case, 10 existed twice. You can also use the sorted function and return the sorted list, but this will not change the original order of the list. However, the sort method sorts and modifies the original list. The default order is in ascending order. However, you can sort a list in descending order by specifying an argument of reverse equals true. Next is tuple. Tuples are the same as list, with an exception that once data are entered into the tuple, it cannot be changed. Think of tuple as an immutable version of list. You can create a tuple using parentheses instead of a square bracket. You can also iterate, access elements, and do the same indexing and slicing tricks, but you cannot change, add, or delete elements in a tuple. For example, you'll receive this error message that says, tuple object does not support item assignment when you try to modify its content. There are no methods like append, extend, or remove for you to manipulate a tuple's content. However, you can extend a tuple using the plus operator like this. You can create a new tuple and then assign the previous one plus the new one. You will often see tuple used in this what we call tuple unpacking. This is where expressions are evaluated by Python in parallel. For example, you can assign values to multiple variables at once. Same thing can be achieved even without the parentheses. You can also unpack a tuple and then pass it to a function that requires multiple arguments, such as this average function that takes in 3 arguments and then computes the average. This asterisk denotes a tuple and then unpacks it when passed as an argument so that individual values can be received by this function. Third is dictionary. Dictionaries are Python's implementation of a data structure that is more generally known as an associative array. While in a list, you can access an element through its index, a dictionary is a collection of key-value pairs, where each key-value pair maps the key to its associated value. You can define a dictionary by enclosing a comma-separated list of key-value pairs in curly braces. A key-value pair is denoted with a colon, as in key:value. This dictionary, or simply dict, consists of 3 key-value pairs. Note that keys in dictionary must be unique, and it can be of any type, such as string, integer, tuple, and so on, as long as it is a hashable object, meaning its hash value never changes during its lifetime. For example, you can get the hash value of this key1 using the hash function. Python uses a hash algorithm to calculate the hash values. Hash values are actually large integers used to compare dictionary keys during a dictionary lookup. Similarly, you can also create an empty dictionary by not placing anything inside the curly braces. You can access element or value in a dictionary by specifying the key. Similar to a list, you use square bracket notation. But then, instead of specifying an index, you provide the key. For example, to access an element with a value of Joed, I need to provide the key 101. Or, you can also use the get method and pass in the key as an argument like this. You can modify a dictionary element by simply assigning a new value to it. You can easily add another key-value pair to a dictionary by simply assigning a unique key with a corresponding value. Or, you can use the update method to append a single or multiple key-value pair items. To delete a dictionary item, you can use the del keyword similar to deleting a list. Or, you use the pop method when you want to return the deleted value of the specified key. Popping an item where the key doesn't exist triggers an error. So you might want to use the in operator to check first if the key exists in the dictionary. This returns a true or false value. So key 104 does not exist and key 101 does exist. To delete an item and then return the key and the value contained as tuple, use the pop item method. Note that the later versions of Python starting 3.7, the pop item method removes and returns the last item that was inserted into the dictionary. This is similar to a stack operation. And of course, the clear method clears the entire dictionary content, similar to the list clear method. You can also use other methods like keys to get all the keys in a dictionary. The values method returns all the values in a dictionary. And the items method returns the key value pairs. You can also make use of these keys values, and items methods to loop over a dictionary. So for example, when you use a for loop in a dictionary, you are implicitly iterating over a dictionary key. You can explicitly do this with the .keys method, and the output will be exactly the same. You can loop over the values with the values method. And you can loop over the items method to access both the key and the value at the same time using tuple unpacking. Again, starting from Python 3.7, the order of insertion is preserved for dictionaries. This means that when we loop over the keys or the items, we get them in the order in which we originally added them. But note that this was not the case in the previous versions of Python. Last is sets. Sets are a collection of unordered elements that are unique. It means that even if the data is repeated more than one time, it would be entered into the set only once. Similar to dictionaries, sets are created using curly braces, but instead of providing a key value, you only provide the value. Notice the duplicate entries for Manila is only considered 1 in set, and items are in no particular order. You can add items to a set by using the add method. You can also remove an item using the remove method. But you cannot use index to access a set element because it is unordered. Similarly, you can check if an item exists in a set using the in keyword. And you can also loop over a set. There are other methods that you can use to perform typical sets operations like union, intersect, difference, and symmetric difference. Let's check these methods using these two sets, set A and set B. The union method combines the data present in both sets. Notice that duplicate values 3 and 4 are only used once. You can also use the set operator using the pipe operator symbol to accomplish the same union operation. The intersection method finds the data present in both sets only. This operation can also be accomplished using the ampersand operator symbol. The difference method returns the set difference of two sets. For example, the set difference of set A and set B is a set of elements that exist only in set A but not in set B. You can achieve the same operation using the minus operator. The Python symmetric difference method returns the symmetric difference of two sets, such that the symmetric difference of set A and set B is the set of elements that are in either set A or set B, but not in their intersection. So it's like a union without the intersection. You can also achieve this using the caret operator. There are situations when you want to create a new list or dictionary from an existing collection or sequence. For example, to create a list that stores the squares of numbers from 1 to 10, usually you would create an empty list. Then, use a for loop to iterate through a list or range of numbers, access each element, perform some computations to it, and then append each computed value to your new list of squares. But in Python, there is what we commonly known as comprehension. This offers a shorter syntax when you want to create a new list based on the values of an existing list. Basically, it uses the same for loop statement, but much more concise. So using list comprehension, you would do something like this instead. Create a variable, and if you are creating a list, use a square bracket, but inside it, you can apply the for loop. say for I in range 1, 11, and then prior to this, we provide a code of what we want to collect. In this case, the square of each I from 1 to 10. And you see that this code accomplishes the same task of creating a list that stores the first 10 squares. Aside from this, we can also filter the elements that will be included in the list by providing an if statement. Say, if we want to collect all the squares of the first 10 numbers, but only include those that are divisible by 4, in effect, it only includes 4, 16, 36, 64, and 100. Although we can accomplish this using several different approaches, but comprehension is commonly used as it is more compact. You can also create a dictionary using this technique. And same with the list, we create a new variable, but since this is a dictionary, we enclosed everything in curly braces. The loop and condition part, if any, is the same as you would do with the list. But the main difference is this. You specify the key followed by a colon. So I'll use the value of I for the keys. I'll convert it to string just to show you that keys could be of any type. And you see the key value pairs of the first 10 squares is stored in a dictionary. There are also instances that you want to use comprehension, but don't want to store it in a list or a dictionary. Instead, you can use it directly for computations like passing the values to the sum function like this. This code gets the sum of the first 10 squares and then prints it. Very concise. This is known as the generator expression. It saves time and memory, especially when dealing with large amount of data. You can even apply nested loops in comprehension. Consider this 5x5 sequence of multiplication table that you would normally do using nested loops. So we have 1, 2, 3, 4, 5, 2, 4, 6, 8, 10, 3, 6, 9, 12, 15, and so on. We can use comprehension to accomplish the same task like this. Create a variable, and then inside these square brackets, I'll specify the outer loop, and then the inner loop, and then finally, the value that will be stored in the list, which is I times j. Since lists, tuples, dictionaries, and sets can collect any type of data, you can basically create any advanced structures of mixed type. For example, I can create a list of students, and each item in the list is a tuple. It means we can modify the list content, but each item inside the tuple, which represent each student record such as first name, last name, and grade, are not editable. I can access the first student in the list like this. Or I can access just the grade of the first student in the list like this. I can apply list comprehension and print only the students with a grade of 70 and above. And this expression returns only 2 students from the list. Now, let me create a different version of this list to include a dictionary. So instead of just an immutable grade as one of the items in a tuple data structure, I'll create a dictionary, which is both ordered and mutable. Now, I need a key value pair for this. Say that the grades consist of several key value pair items. For a math key, this is the value. And then for the science key, this is the value. I'll copy-paste this and create a dictionary of grades for each student item. So now, we have a list of students where each item in this list is a tuple, and each tuple consists of string element for the names and a dictionary for grades. And then, each dictionary item has a key of string and a value of float. So let's try accessing the first student in the list. Now, I'll access only the first student's grade. And if I want to be specific, I only want to access the math grade of the first student in the list. Now, since this is a dictionary, I can modify its value like this. And then, prints the updated value. I can also apply comprehension to this, such as retrieving only the students where the science grade is greater than or equal to 70. And as a result, we only have 2. So, as you might have noticed, we are barely scratching the surface on how deep we can go in creating any virtually complex data structures using only these 4 basic built-in data structures in Python. Honestly speaking, one of the most important data structures that you will be using in machine learning is array. Arrays are important because they are used in linear algebra, and this is the most useful and powerful mathematical tool at your disposal. You'll appreciate this when we start dealing with vectors and matrices. So now you might ask, does Python have built-in array data structure? Actually, yes, but most programmers rarely use it. This is because of much better alternatives. When working with built-in linear data structures in Python, most programmers would prefer list over array due to its flexibility. However, when performing powerful tasks in terms of mathematical calculations and modeling, you would use an external library for this, the NumPy array. So up next, we'll discuss Python data analysis with NumPy and Pandas, so we can advance in building our first machine learning models in the succeeding videos. Again, thank you very much for watching, and if you learned something of value here, please click the like and subscribe button for more programming tutorials. This is Joe Edgo, and hope to see you again in the next lesson.